Now, today we shall discuss the AC generator here. Okay, and before that, we consider a general case for the currents flowing simultaneously into nearby coils. This is a case for mutual inductance and self inductance together. Try to understand. The flux linked with one coil will be the sum of two fluxes which exist independently. Consider a general case currents flowing simultaneously in two nearby coils. Now see, one coil is there where current I1 is flowing, the other one is having I2. Okay, they are the currents in first and second coil. Now flux linked with first coil is due to self-inductance and the mutual inductance, and it can be represented as, see, flux associated with first coil we are talking. So it can be N51 is equal to M11 I1, that is due to self-inductance, and plus M12 I2, that is due to mutual inductance. Now M11 is nothing but the inductance due to same coil, that is self-inductance. Okay. Now you take the differentiation of this. Okay. Then differentiation with respect to time of this flux will give you electromotive force. And according to Faraday's law, it must be negative. So minus sign is taken on the right hand side. So it becomes minus M11 di1 by dt minus M12 di2 by dt. It means that you are changing the current in first and second coil with respect to time. Differentiation means now that electromotive force will be generated in the first coil, and that is because of its self-induced electromotive force, and that is due to the mutual inductance, the electromotive force will be generated. So two effects are seen simultaneously. Okay. Here M11 is the self-inductance of the first coil, which can be replaced by L1, and M12 is the mutual inductance of system of two coils. So this can be represented as E1 is equal to minus L1 di1 by dt minus M12 di2 by dt. So this is the case of both the inductance, self-inductance and mutual inductance together. Okay. Now we move further for the AC generator. The Yugoslav inventor Nikola Tesla is credited with the development of the machine. Okay, and this principle used is electromagnetic induction. That is the main principle which is used in this AC generator. Now one method to induce an electromotive force or to produce electric current in the loop is changing the loop's orientation or a change in its effective area. Try to understand, when you are moving the orientation or when you are changing the orientation of rectangular coil, if it is rotated between the two poles of magnet, say this is north pole and this is south pole, and you rotate this kind of rectangular coil, then its angle, that is area vector, is making an angle with the magnetic field. Say magnetic field is in this direction, and you have placed, say for example, the rectangular coil, say this is north pole, this is south pole, and you are placing this coil in this way. So area vector is in this direction, magnetic field is in this direction. So angle between area vector and magnetic field is 0. Now when you rotate this, then area vector is making different angle at different time interval with magnetic field. So the flux associated with this continuously changes, and as due to change in flux, the electromotive force and induced current is produced. When coil is placed in a magnetic field B, the area vector makes an angle theta with magnetic field. As the coil is rotated, what will happen? The magnetic field and area vector, they will have different orientation at different time interval, or we can say the angle theta continuously changes, that is between area vector and B. Okay, so any time if you have the component of area, that is A cos theta, try to understand, if you have this north pole and this is your south pole, okay, the magnetic field is in this direction and the area is in this direction. Now vector of area and vector of magnetic field, they are perpendicular. Now if you change the orientation of the coil, say for example you have placed the coil like this, it makes certain angle, then area vector and magnetic field, they are at certain angle theta, then the effective area that is in the direction of magnetic field, say this is your area vector and this is the direction of magnetic field. So effective area vector in the direction of magnetic field is A cos theta. So this way, as theta changes, the value of this A cos theta also changes. So flux associated with this area continuously changes, and due to that the induced electric current is produced. That phi flux is Ba cos theta. An AC generator converts mechanical energy into electrical energy. You have to rotate the coil, otherwise on its own that is not producing the electromotive force. Okay. Now this is the construction which I tried to explain. This you must have studied in your 10th standard also. North pole and south pole are there, and they are producing the magnetic field from left to right, and this coil is rotated around this axis of rotation which is called axial also, and this can be rotated in this clockwise direction. And here there are slip rings and there are carbon brushes which are taking out the electric current which is produced. And if you place a galvanometer here, then that galvanometer will show the deflection, or you place a bulb, then the current will pass and the bulb will glow. Okay. So this is all about the construction of this AC generator. It consists of coil mounted on a rotor shaft. Okay. The axis of rotation of the coil is perpendicular to the direction of magnetic field that I tried to explain. This is the axis and this is the direction of magnetic field. Both are perpendicular to each other. Okay. The ends of the coil are connected to external circuit by means of slip rings and brushes. Okay. So the ends of the coil are connected with the slip rings and the carbon brushes. Okay. How does it work? Now what you have to do, you have to give some constant angular velocity. Okay. The coil is mechanically rotated in the uniform magnetic field with constant angular speed omega. Okay. You have the omega as a angular speed by some external means. Either you have a hydropower station, then it is rotated by the flow of water. Okay. The rotation of the coil causes the change in magnetic flux. So magnetic flux changes through the coil. Okay, as angle between A and B continuously changes. Where what is A? A is area vector, B is magnetic field. Angle at any time. Say for example, initially you have kept the coil in this way. So area vector and magnetic field both were in same direction. So angle theta was 0. This is for simplicity we are taking. Now angular speed is omega. So angular displacement, as you know, angular speed is angular displacement, that is angle subtended is theta upon time. So theta will be omega into t. So at any time t, the angle which is made by this coil with the magnetic field will be omega t. Okay. So EMF is induced in the coil and flux is nothing but Ba cos theta. Theta is omega t. So Ba cos omega t. Now that flux changes. So you are taking the differentiation according to the Faraday's law. E is equal to minus n d phi b by dt. And if you take the differentiation of cos omega t, then that differentiation of cos omega t is nothing but minus sin omega t. So what you are doing here, as such, the flux phi is nothing but NBA cos omega t. Now if you take the differentiation, then this becomes d phi b by dt, and according to Faraday's law, E is equal to minus, as such, this d phi b by dt. Okay, so number of turns are n, so n d phi b by dt. So we have to take the differential. Minus sign is because of the Faraday's law and Lenz's law. So minus sign we have to place. So minus n b a, that minus is for Lenz's law, and then it becomes d by dt of cos omega t. Okay, so minus n d phi b by dt. So flux is ba cos omega t, and that ba cos omega t we have written, and then we take the differentiation of this whole term. Okay, then it becomes minus nba d by dt of cos omega t, and the differentiation of cos omega t is minus sin omega t, and omega is in multiple of t, so we have to multiply it by omega according to chain rule. Then this EMF will be nba omega sin omega t, that minus of this, that is minus of differentiation and minus of Lenz's law, they will cancel out, and that will give you positive sign of electromotive force, that is nba omega sin omega t. nba omega is the maximum value of EMF. You can understand, if you take sin omega t as plus or minus 1, then this nba omega is maximum, and that is denoted by E0. So our equation will become epsilon or E is equal to E0 sin omega t. Since the value of the sine function is varying between plus 1 and minus 1, the sign or polarity of electromotive force changes with time. Once one terminal becomes positive, then after some time next terminal will become positive. So alternately polarity is changed. Okay, so electromotive force has maximum value as when theta is 90. Theta is 90 is become plus E0, and when theta is 270 it becomes minus E0. So it changes its value from positive to negative as the change of the flux is highest at these points. Change of flux at 90 degree and change of flux at 270 degree will be maximum. Why? Because you can understand that initially, say, the coil was like this, so maximum field lines were passing initially at t is equal to 0. Now say at 90 degree, what will happen? This will become like this. Okay, parallel, or area vector is now perpendicular to the magnetic field. Area vector is perpendicular to magnetic field, then theta becomes 90 and flux becomes 0. So the flux has changed from its maximum value to 0. So flux change is highest at 90 degree, then similarly the flux change is highest at 270 degree. So maximum flux is getting changed at these 2 points, that is theta at 90 and theta is at 270 degree. Okay, so the EMF has its maximum or rather extreme value at theta is equal to 90 and theta is equal to 270. Okay, the direction of the current changes periodically, and therefore the current is called the alternating current. Now omega is 2 pi nu, so instead of omega we write 2 pi nu. So Fe is equal to E0 sin 2 pi nu into t. It becomes, okay, where nu is the frequency of revolution. Okay, now this is the picture that is shown in the textbook. Initially the coil which I tried to explain is in this particular direction, so that what happens, the area vector and magnetic field is having angle 0 between them. So at that time the flux is maximum and electromotive force is given by E is equal to E0 sin omega t. So at t is equal to 0, sin 0 it becomes. Okay, so minimum value of electromotive force, that is 0. Now when 90 degree this angle becomes 90 degree, omega t is pi by 2, then what will happen, this area vector and magnetic field, they are perpendicular to each other. So The flux has cos function, try to understand, it is NBA cos omega t. So at this 90 degree this flux becomes 0 and electromotive force becomes maximum. Then when you make the angle 180, then area vector is in this direction and magnetic field is in this direction, both are opposite. Okay, the angle is 180, so again sin 180 is 0, so electromotive force is 0. Then at 270, again what will happen at 270 degree, this figure you can understand the here area vector is in this direction, magnetic field is in this direction, 270 degree is the angle, so E becomes negative, so negative value is obtained, maximum negative value. And similarly at 360 again the electromotive force becomes 0 because sine function is having its value 0 at 180 and 360, so they are giving you 0 value. At 90 it becomes positive and at 270 it becomes negative, so their values are alternately changing their, or rather electromotive force is changing its direction alternately. Okay, thank you very much. Here our chapter is ending. Next time we shall discuss some of the numericals. Okay, thank you.